that it eliminates the necessity of internal wiring in a circuit. So, in the form of having copper plates that are etched on a copper board. Okay. So, what are the items that are necessary to make a PCB at home? So, we have something. We first need a circuit of something which we are going to develop. So we need a mirror image of a circuit which is developed by a software that is available online. A lot of software which are available online can design circuits, and these circuits have to be taken, a laser photocopy of these circuits have to be taken on a photoglossy paper. A photoglossy paper is something that's available in all stationery shops, should cost about around rupees 10 or so. Okay, so that is the first thing that you would require. And the next thing is an iron press, a very hot iron box that you would require. And you need something to imprint the circuit on, and that will be a copper clad board. About a board of around 6 cross 6 inches would cost you around 20 rupees. Okay, and we need hot water. We need a steel sponge, which Abhinav will show you. A steel sponge is very similar to what you get as Scotch-Brite in shops. And we need ferric chloride solution. Ferric chloride is available in the form of a powder, which you will be making it in the form of a solution, which you'll be using in the form of a solution. Okay, so Abhinav will start the demonstration. So the first thing that you require is to take the board, and you will have a copper-sided face of the board. The other side is pretty rough. The one side of it is covered with copper. So first thing you need to do is use the steel sponge that you have and wipe it thoroughly. This is done just to eliminate certain greases, grease chains, and certain impurities that are present on the board. Okay, so you wipe it thoroughly. You wipe it thoroughly until it becomes a highly polished surface. Okay. And what Abhinav will be doing here is a circuit of a water level indicator circuit. So what exactly is this? Is this when you have an electric motor at home, you would have to raise the water from the ground level to your tank. So that is where a water level indicator or water level circuit which comes into play. You will have an automatic start and stop of the water flow into the tank when you have such a circuit. So when the tank is full or crosses a certain limit, the motor switch automatically switches off. And when the water becomes low by a certain extent, it starts filling up with water once again. Okay, so here Abhinav has thoroughly cleaned that side of the board, and you'll have a shiny, polishy surface. And what he has in his right hand is a mirror image of the circuit, a water level indicator circuit that he's got from the internet and got photocopied it on a photoglossy paper. You have to place that sheet. You will have to place the circuit face upside down or facing downwards on the sheet, on the plastic plate, on the copper side of the plate, and use a hot iron and start pressing over the plate. Okay, has to be done carefully for about around 2 to 3 minutes until a point where the paper turns a light tinge of brown. So how economic is this process? In the meantime, how economic is this process? A normal printed circuit board, if you get it designed from a shop in the market, would cost you around 25 rupees each. But you would have to take around 50, I'm told, a minimum of 50 printed circuit boards. So that will cost you a lot. For people who are very interested in electronics and working on all these things, this can be done with a minimum cost of around rupees 25 to 30 rupees. Okay, when it is done at home. And these can be done for something called single layered circuits. So what Abhinav is doing here is on a single layered circuit that is on one side of the board. The more complicated equipments that we have multi-layered circuits. For example, the motherboard in our PC at home has a multi-layered circuit. So what he's showing here is a single layer circuit, which So what the pressing does is that it imprints the circuit that was there on the photoglossy paper onto the copper board. The purpose of using copper is just because it is a very good conductor of electricity, and it is available at a modest price. In the meantime, we have a kettle in which hot water is being boiled. So what would happen further is he would be using the hot water and just dipping the board that he is just working on into it, so that, and you would have to remove the sheet of paper, the photoglossy paper, from the board, so that at the end of it we have this circuit that is imprinted completely on the board. Okay, so Abhinav is just filling it up with hot water. Don't make it extremely hot also. So this particular circuit that he is working on, a water level controller or water level indicator, has inductors, it has a microcontroller, it has a few resistors. So instead of using wires to connect each and every component, we use something called as a printed circuit board. So you can just leave it for about a minute or so. So of course, after getting the printed circuit board, you have to solder the necessary components like a resistor and inductor also, and you have to solder it onto the board, and then give the external connections to make the water level indicator or any circuit for that case into a working model. So just peel the paper off the board as smoothly as possible. The purpose of using hot water is just the paper comes out much more easily. So we have the circuit that is imprinted on the paper, on the board. Sorry. Okay. So this is how the circuit will look when it is imprinted on the board. Okay. So the next step will be to use ferric chloride solution. We don't have it today, but what you would have to do is ideally take some amount of ferric chloride powder, put it in a jar, and preferably a glass jar, and pour some water into it, so you'll have ferric chloride solution, and just drop this into it. So what it does is ferric chloride will remove all the copper around the circuit. So the black things that you see on the board is the circuit part of it. So what we want to do is that remove the other copper things that go on the circuit, because copper is a good conductor and we want the conduction to happen only along those lines of the circuit. So you remove all the copper part from it. So when you put it into the solution and leave it for about 15 minutes, keep stirring it continuously. what happens is that the copper around the black circuit comes out. And why doesn't the circuit part of it get damaged? Because of the imprint. Those are called as toner particles, the black things, which act as an insulator, prevent the copper that's lying underneath from going into the solution. Okay. So once you have done that, once all the copper has been removed, so until what point of time should you keep doing this? Until the color of the side of the board that you were working on comes to the same color as that of the back side of the board. Okay, so those two end up with the same color, and that is how it will look when you remove all the copper using ferric chloride solution. So now what you have to do is you have a circuit, but it is covered by an insulator. You have to remove that insulator. Use the steel sponge that you used earlier to just rub it on the circuit, and the black toner particles will be moved away, and you will have the circuit which is ready. Okay. So ultimately that is how the circuit will look. It will have the brownish tinge of copper. Okay, and this is something that suits immediate usage, because copper will undergo oxidation if you leave it for a few days, and it can still be used, but it will not, the lines won't be probably distinctly visible as it is when you immediately complete the circuit. Okay, so this is a very feasible way and very economic way in which enthusiasts can design their own printed circuit boards at home. Okay, so thank you very much. If you have any questions, you can ask Abhinav. Also, a round of applause for Abhinav, who helped us provide a easy solution for PCBs at home. Any questions to anyone? To Abhinav rather. Okay, yeah. Thank you very much. Thank you, Abhinav. Thank you, everyone.